Hello guys and welcome back. So in this video we are going to be looking at some laws of definite integral. To be precise, we have two basic laws that we use a lot in definite integral, and that's what I'm going to treat in. That's what I'm going to be treating in this video. Okay. So the first law we have is this: that when you have the integral from a to b, it is possible for you to swap the limits. But the thing is, once you swap the limits, then you need to attach a negative sign to what you have there. So if I swap the limit, you can see instead of the upper limit being b, now the upper limit is a, the lower limit is b, but now I have a negative sign attached to it. So the left and the right hand side will always result to the same answer. Okay, they'll always result to the same thing. So an example is when you have something like this: the integral from 4 to 2 of 2x plus 1. You can decide to make it the integral from 2 to 4, just that now you have a negative sign attached. So this is one of the practice question I have for you guys. So what you need to do for me is this: solve this expression, solve the left hand side, see what you're going to get, then solve the right hand side with the negative sign, solve the right hand side, see what you're going to get, and see if both results are the same thing, of which both results are meant to be the same thing. Okay, that's number one practice work for you guys. Then the next one we have, the next law we have is when you have integral from a to b, you can decide to put a point in between and it is fine. So instead of me to move from a to b directly, I can decide to move to a point c, then now from c I'll now move to b. So this is how it is. I'll move from a to c. You can see instead of b now I have from a to c, but since I'm moving from a to c, next I need to move from c down to b because my terminal point is meant to be b. Okay, so this is second law. So you're meant to move from a to b, from point a to point b, but instead of moving from point a to point b, decide to put a point in between. So now you're moving from point a to point c, then you move from point c to point b. So as an example, I have the integral from 1 to 7. Now I can put any point. Now it mustn't be a point between 1 and 7. Okay, I can decide to put 9 there. I can say, okay, I want to move from 1 to 9, then from 9 to 7. Is actually correct, but usually we'll put something in between the limits we have. Okay, so from 1 to 7, I can say, okay, let's make it from 1 to 4, and then plus from 4 to 7. So you can say, okay, it should be from 1 to 2, then from 2 to 7. Somebody else can say, okay, it should be from 1 to 1000, and then from 1000 to 7. They'll all give you the same thing. So the second work you have to do for me is this: do the left hand side, integrate the left hand side, see what you're going to get, then integrate the right hand side, okay, which is this, and also see what you're going to get. And both answers are meant to be the same thing. If they are not the same thing, check your work and then try doing it again. Okay, so that's it guys, and this is where we're going to end the concept of definite integral. So in the next video, what I'm going to be doing is to give you the solution to this. Okay, both exercises I'm giving to you here, I'm going to give the solution, but it's not going to be, in fact, just try it first. Try it first before I give you the solution. So I'll give you the solution in that video, and then we'll move down to the next chapter, which is going to be I think it's going to be techniques of integration. Okay, to be precise, integration by substitution. That's what we are going to be looking at in the next chapter. So I'll see you guys in the next video. Bye bye.